All right, welcome back. And today is the first day of chapter 4. Okay, so we have 3 weeks left until fall break. We're going to get one more chapter in here. As another reminder, just stay on top of it. Do a little bit of work each day rather than waiting until the end of the quarter or the end of the chapter and having to do a lot of work. Okay, so today we're going to start off talking about polynomial functions. And this, if we look here at our generic version of it right here, and it's a function where n is a non-negative integer, meaning we have some sort of number there. Okay, an integer is going to be a whole number for us, okay, and it's non-negative. And sometimes there will be a lot of terms, sometimes there's just a few. If we look at these different examples here, like example 1 here, there's x to the fourth and x and a constant, where example 2 just has the x and the constant. Okay. Now, when we are trying to identify the degree of our polynomial, this is, if it's in standard form, it's very easy, which standard form is what we have up here. It's also what example 1 and 2 are. In standard form, it's just what is the largest exponent, okay, the largest value, or the largest power of x is another way to think about it. So on example 1 here, that one, negative 3x to the fourth plus 2x minus 1, is going to have a degree of 4, because that is the highest x value. Now example 2 will just have a degree of 1, because that is simply x to the first. Now example 3, we got to be careful on this one. This is what we are going to call factored form. And the reason it's called factored form is because it's broken up into the parts, into different factors. So that's factored form. And typically with factored form, you're going to have a bunch of different sets like this. Okay. Now, if we think about it, if we would multiply this all out back into standard form, this x would come in there, and then we'd multiply it again. So what we need to do to find our degree is simply add up all of our x's. So at the front here, we have 2. Right here, we have another 1. And here at the end, x, but it's to the third, so it'll be 3. So 2 plus 1 plus 3 gives us a degree of 6 for that one. So all 3 of these are examples of polynomials. Okay. Once again, they have whole numbers for their exponent and non-negative. Sometimes not everything, just because it has an exponent, is going to be a polynomial. If we look at example 4, we can't think of it, no x's can be in the denominator. Because hopefully you guys remember, but if not, if that x is in the denominator, that's the same as x to the negative first, okay? And we cannot have a negative exponent value. The second one does not work because we said we can have no fraction exponents. Now the third one is a little tougher because I'm guessing some of you have forgotten this, but remember, another way to write this, we can have, let me do this in blue, no square roots, because a square root is the same as x plus 7 here to the 1/2 power, which, as we said, we can't have. So no square roots, no cube roots, no roots of any kind, because those are fractional exponents is another way to write them. Okay. So now, the next thing we're going to talk about today is, if we have a polynomial, how to find the zeros of that function, and also their multiplicity. Okay. Now, what I mean by this, zeros you can probably already know. Okay. Zeros, that's another way of saying the x-intercept. All right, so we'll start off the zeros on this. Simply set each of these terms equal to 0. So if we had, like, over here, I'll do it, x plus 2 equals 0, then we just solve, and x would equal negative 2. So negative 2 is 1, and if we did the same thing for the next one, we're also going to get 3. Those are my two zeros. Now, the multiplicity just simply means how many of them are there in the function. Okay, so both of these have a multiplicity of 1. So I'm just going to put m1 because there is 1 0. Now, initially you might think, well, why do I care how many there are? However, as we get into graphing later in this chapter, it will be very crucial for what the shape of the function looks like. So, on this next one, x plus 7, if we set that to 0, we'd get negative 7. That has a multiplicity of 1. X plus 5, we'd get negative 5. That has a multiplicity of 1. Now, x minus 1, if we set that equal, we get 1. That one has a multiplicity of 2 because it is squared. Okay, so the key thing right here, it was squared, so we know it has a multiplicity of 2. Okay, now, on example 9 here, this first one, this x, some of you might be tempted to say 1, but if we think about it, if we follow that same rule we did over here, if I do x equals 0, that's all it would be, because that is all that the first term is. So we know it could be 0. That has a multiplicity of 1. Okay, it could also be negative 4. That has a multiplicity of 1. It could also be 2, and that has a multiplicity of 3. So once again, we haven't talked yet about why the multiplicity matters. However, as we get into graphing, this will start to be evident why we care. So the final one here, right here, we're going to start with the negative x squared. If I set that equal to 0, I would divide by negative 1 and then take the square root, and we're going to get 0. Now that one was squared, so that has a multiplicity of 2. Okay, now the next one, to do x squared plus 9. If we set x squared plus 9 equal to 0, we subtract that 9, we're going to get x squared equals negative 9. And if we take the square root of a negative, we're going to get something imaginary. So in terms of our roots, our real zeros, we cannot get any from that. Okay, so I'm just going to put no or none because there's no roots or no real zeros that come from that. Now, let me make this a little bigger. I need a little more space. Our next one, I'll do this in red right up here. If I take x squared minus 9 and set that equal to 0, if I add the 9 over, I'm going to get x squared equals 9, take the square root. X will equal plus or minus 3. Okay, so we have to put them both here. We have 3. We also have negative 3. Both of those would just have a multiplicity of 1. And then your final one over here, the x minus 10 cubed, so it'll be 10. And that one will have a multiplicity of 3. All right. So, as you can see, right now it's kind of like, what does multiplicity mean? Think of it basically as how many are there, okay? So in our case here, there was raised to the third, so we knew that was multiplicity of 3. Now, as we take a look onto the back, we need to think about how can I write a polynomial. Now, thankfully, I am not going to make you multiply it all out into standard form, at least yet. And so how do we write it in factored form? So, first thing, it tells us write a polynomial function of degree 3. Okay, and it has real zeros at negative 7, negative 5, and 2, all with multiplicity of 1. So we start off, we know it's f of x equals. Now, it's basically saying what value would I have such that we would get the, I'm going to go ahead and turn on the light in this room real quick. So, sorry. What value of, if we would plug in like a negative 7 for x would give us 0. So we think of it kind of as like the opposite. So in our case here, we need x plus 7. Okay, the reason why, if I plug in that -7 for the x, -7 plus 7 gives me 0. It tells us here we have a multiplicity of 1 for each of them, so we're good on that one. Now we also are going to need x plus 5. And then finally, x minus 2. Okay, so those are my 3 different parts of it, my 3 different factors, and we can just leave it as such. Now the next one is a little bit more complicated. It says write a polynomial function of degree 5. So we know there will be 5 x's total. Now that doesn't mean we're going to have x written 5 times, but if we would add them all up, it'll equal 5. Okay. It has real zeros of -1 with a multiplicity of 1. So let's start with that one. So we do the opposite, x plus 1, and this has a multiplicity of 1, so check that off. Okay, then it has also 2, so we got to do the opposite, -2 with a multiplicity of 1, so check that off. Then it has 3, and that also has a multiplicity of 1, so check that off. And then finally, it has a multiplicity of 4, or sorry, it has the value 4 is a 0 and a multiplicity of 2. So if we want to look quick, there's 1, 2, 3, 4, 5, and we are good. Okay. So now, the reason this matters is multiplicity will help us as we start to graph it. We need to think about, as we're graphing these, our goal is to be able to look at a function and know the general shape of what it looks like. Okay, so what is the end behavior of our shape? And what I mean by that is, you guys hopefully know f of x equals x squared here, the just generic one. If we would graph this, it's going to look something like that, right? It has 2 arrows that both are pointing up. And likewise, if it's -x squared, both of them are going to be pointing down. Okay, so if it's an even degree, both arrows will be pointing the same direction. Okay, and if it's a positive even, they'll both be pointing up. If it's a negative even, they'll both be pointing down. So you might want to make a note, maybe positive up, negative down, if you can't remember that. Okay. Now, on the other hand, an odd degree, if we were to graph f of x equals x cubed, we're going to get something like that. And if we graph -x cubed, something like that. You know it flips it. Okay? So, for this one, you'll see with an odd degree, they always are going in opposite direction. If it's positive, it ends by going up. And if it's negative, it ends by going down. So, these pictures, what we want to do, we want to sketch the end behavior for each of the following functions. And the way we can do that is first establishing the degree. So since the degree is 7 on this, and remember we got that from right there, okay, it also is positive. We need to identify those 2 things. So if it's a degree 7 and it's positive, then our end behavior, it will start low and end high. Okay, so that's not what it looks like, but it's going to look something along those lines. It will start from bottom and end pointing up. Okay, so our next one. This is already in standard form. The highest value is a 10, so degree 10. So now we're worried just about the even types. Now this one is negative. Okay, so we know it will start from below and continue down to below. Okay, so take a minute if you want, pause the video, try these next few examples. Example 15 here, the highest one is degree 6. This is positive. So the end behavior, once again, this is not what the shape looks like, but it's what the ends look like. As we get into tomorrow and the rest of this week, we'll see more of what this means. But we know it will be something like this. Okay, example 16 here. It is degree 3, and it is negative. So the ends, it will start high and go low. Now, examples 17 and 18, we have to kind of calculate what the degree is. And it's not hard, but we just got to add up our x's. So 3 plus 1 is 4, plus 1 is 5, plus 2 more gives us 7. So degree 7. Once again, this 2 is why I counted 2 for the last one. And it has a negative at the front. So degree 7 and it's negative, that's odd and negative, so it'll be going down, something like this. Okay. And then the final one, we have 1 plus 3 more, so that has a degree of 4, and it is positive, so we know that we'll start from above and it will continue back up to above. Okay, now, the reason multiplicity is important, and we kind of already touched on this, and we'll continue to talk about it tomorrow, but multiplicity, oops, I forgot an L, is important because it helps us determine, as it comes towards it, if it will cross through the x-axis or if it will touch it. So just make a note here, if it's even, we know it's going to touch it, and if it's odd, we know it's going to cross through. Okay, so let's find all the real zeros and then tell if their multiplicity touches or crosses at the 0. Okay, and so this first one right here, negative x to the third, that's going to be a 0 as a multiplicity of 3, and since it is odd, we know it will cross. Now, some of you might be saying, what does he mean by cross? If you look up here, a parabola is an example of something right here that touches. It goes and it hits the x-axis and touches it right there. It does not cross through. Once again, because that's even. But if it's odd, as we said, it will cross through. It hits the x-intercept and it keeps passing through. So that's what we mean. So 0 has a multiplicity of 3 and it would cross. Okay, our next one. Right here, the opposite of that, negative 1, multiplicity of 1, which that is still odd, so once again, it will cross. Then we have 1 from here. Again, multiplicity of 1, and that will also cross. Now this final one, think to yourself, x squared plus 4 equals 0. If we subtract 4, x squared equals negative 4. We cannot take the square root of that. Okay, the square root of a negative would give us plus or minus 2i, and that is, if it has an I, that's not a real number. Okay, so it's not a real 0. So we'll get more into that later, but for now, we can say there's no real zeros or none from that one. Okay, so we're just about done with our notes for the day. This final one now, we got a real 0 of 3 with a multiplicity of 1. And at that point, it's odd, so we're going to cross. And then this final one right here, it's going to be negative 5, multiplicity of 2. And so anytime it has an even, then you know it'll just touch. Okay, so I know today's notes were a little longer. Go ahead, please look at the It's Learning assignment. Let me know if you have any questions. Please try to stay on top of things, okay? I know it's almost fall break, but we got to finish strong. One more chapter. Have a great day.